Hello my colleagues, welcome back to Softwaring. Today I come back with another Ansys tutorial on how can you do the analysis of shaft by using Ansys workbench. So as you know the drill, before the shaft is a mechanical element which used to transfer the rotational energy from the source to the output. So as you know the drill, when the torque is applied on the shaft will twist by some angle, and also there will be a stress which called torsional stress or shear stress. So in this particular video I'm gonna show you how can you do this or how can you know the maximum shear stress and the maximum twisting angle or the total deformation of this shaft under the given twisting moment. So in this video I'm gonna show you how can you do this step by step. Keep watching. To start with, let us open our Ansys workbench. So Ansys workbench will look like this. So there are different components of the analysis system of Ansys workbench on the Ansys toolbox. So to start with, let us open or double click on the static structure. Once the project schematic is open, the schematic original order will be put like this. So the name static structural, the engineering data is ready to proceed to the geometry. So the structural steel is a default material for Ansys workbench. So let us take as it is, and then let us proceed to the geometry part. So double click on the geometry. The Ansys design modular will open like this. So there are things we do step by step. So the first thing what I have to do is just creating the geometry or model the shaft and the gear by using Ansys workbench. So to start with, let us check the unit. So let us select inch system and start our sketch. So the first thing what we have to do here is that we have to create the gear first. To create the gear, let us create the tools first. So to do that, let us you can watch the steps here. Let us select a construction point and let us put different construction lines at different place. And then let us dimension it. And the dimensions are 0.18, and also this one is 0.69, and this one is also 0.02. Again, this one. By the way, you can use different dimensions as per your tool size. And for this analysis, I'm using this dimension for my two sizes, and then let us proceed to another form of dimension. So these are the construction points for our tooth geometry. So let us create the spline on those construction points. So let us hold the spline command here and let us sketch here. And then from modify, let us edit this spline. So spline edit, let us select this and refit the spline, and then let us do other operation to create our gear. So let us create different circles. So let us hold the circle and so let us dimension those circles. This is 2.2 inch and this one is 1.5 inch. And then let us draw a line. Let us connect this spline to this circle, and then let us create a circle around here and let us dimension it. .2 inch, and then let us apply some constraints for this circle. Let us select tangent. Let us make it this line is not tangential, and also this and these are tangential. Then let us modify. Let us trim this line and also this part. Now it's ready for creating our tooth profile, and then let us do other operation. From the modify tool sketching toolbox, let us select replicate and let us select the angle as 9 degrees first, and then let us select this line, and this line. Then let us click, let us use the plane origin as handle, and then let us rotate by this angle and let us click here. Before that, let us make it flip horizontal. So if you click at the origin, we create our tooth profile. So similarly, let us do the same operation for the next teeth. So let us make it 8 degree rotation, and let us select all those profiles. Let us do the same thing. And also let us adjust our angle to 36, and then let us select all the tooth profile. And then left click, let us use origin as a handle, and then rotate by R. Let us click at the center. Let us repeat this procedure up to 600 degree. Once we finish this operation, we already create the tooth profile. Then let us trim some unnecessary parts from this sketch. So let us trim some unnecessary parts. Once we trim unnecessary parts, let us extrude our profile, our sketch. Let us the direction, let us make it both symmetric, and the thickness is 1 inch thickness face width. So let us generate our gear. So this is our spur gear we create by using design modeler, and then let us create a plane and let us generate it, and let us sketch on this plane. So let us create our circle here, and then let us dimension it as usual. So this gear has 1.25 inch radius, and then let us dimension it, let us generate it. Let us select this sketch, and then from operation let us change the add version to make it the shaft and the gear independent, and also the direction is both symmetric, and also the depth will be 6 inch on both sides. So let us generate it. So this is our shaft and gear assembly, and then let us create some face for frictionless support and fixed support location. So we have to split the face of the shaft. So to do that, let us create different planes. So let us transform offset to the z direction. So the first will be 4 inch. Let us generate it. Similarly, let us create a plane, and this base is xy plane, and also the transform will be similarly the z direction, and its depth will be -4 inch in the reverse direction. And also let us generate it, and also let us add other 2 planes. This is 5 inch, very nice. And then let us, the final plane will be, by the way, the reason why we create these different planes will express, or will get the point when we do the next thing. So watch as it is. So let us generate, and then from tools let us hold the face split command, and then face split type will be by using planes, and then the target face will be this, and then the plane will be the first plane. Let us generate it, so we get different faces here, yeah. And then let us do the same thing. Let us hold the face split command, then let us change the face split type by using plane. Also the face will be this, the face will be this one, and also the plane will be plane 7. Then let us generate it. So we have different planes here, this one, and this one. Similarly, let us hold the face split command here, and then let us change the face split type by using plane, and then the face target will be this one, and also the plane will be plane 6. Let us generate it, and we will have 2 different planes, and let us do the same thing for the last time. And the plane will be plane 9. Let us generate it. So as you see from here, there are different faces. This will be for fixed support, this will be for frictionless support, and this will be the shaft surface where the load is applied, and this will be for frictionless support, and this will be for fixed support. So we already do what we intend from the design model. So let us close this and proceed to the next step, which is model. So as you see from here, the model is ready for refresh. So let us double click here. The mechanical and circuit will open as usual. So to check step by step from the project tree, as you see from it, the first thing is geometry. So we have two independent gear and shaft bodies, and then let us proceed to the material. Both the shaft and the gear are made of the structural steel, and also the coordinate system is around this point. And you can check even the connection, since we create two different bodies, gear and shaft, as you see from here. This shaft is bonded with this gear surface, so the type of the type of contact is bonded, so it is sufficient for our shaft analysis. And also let us check the meshing. So let us insert some refinement on the surface, and let us select all the surfaces, because when the body is meshed on the in fine manner, we will get some accurate result. So let us generate this mesh. And now it is the time to apply some boundary condition for this system. So as you see from here, the gear is spur gear. So if the power is transmitted by using spur gear, there is no any axial load. That means the only force that applied on the shaft is radial and tangential. So putting or fixed one side of the shaft is enough. So let us insert the fixed support on this face, and then let us assume that there is a bearing at this face and at this face. So there is a frictionless support as those blue surfaces, and then let us apply the twisting moment or torque on the face of the gear. So this moment is defined by components. So in the z direction, 5 A4 magnitude. So this magnitude of twisting moment is applied on the gear face. That means it directly transferred to the shaft. So this shaft is twisted by this amount of twisting moment or torque. So from this boundary condition, or from this analysis, we can see the total deformation or the total twisting angle of the shaft, and also we can get the total equivalent or normalized stress, and we also see the factor of safety and other parameters of the shaft. And another interesting thing on this is if the gear is not spur, if this is a helical or a worm gear, there will be some axial force component. So that force requires some other bearing. So those two bearings were ball bearing. So if the gear is a helical or other, it will induce some axial force on the shaft. So thrust bearing and other will be recommended. So in this particular video, we just assume that two ball bearings are used at the two ends. So let us solve by this boundary condition, then we will see our final results. Yeah, once the solution is done, we can see different result of this shaft. So as you see from the total deformation is like this. So by ignoring the result of the gear, we can consider the result of the shaft. So as you see from here, the shaft result will be around here. So it will be, or let us use some probe. Let us use some probe deformation. So the deformation as this face will be let us solve the probe deformation. So the probe deformation will be this magnitude. Anyways, let us process the total deformation. So this deformation is a linear distance. So we can change into angle. So that amount of angle will be twisted, or the twisting of the shaft due to the twisting moment or torsion. And also we can, if you want to see the animated result, you can press here. So this is how the system is animated due to the twisting moment. And also we can check the equivalent stress. So as you see from here, the equivalent stress will be maximum on the fixed side of the shaft, because on the free side will be twist freely. So if there is some free twist, the stress will be somewhat minimum to the compared to the opposite side of the shaft. And also, if you want to check the factor of safety, that means can this shaft withstand the load under the circumstance or under this loading condition. So the minimum factor of safety is 0.24, so it is absolutely in danger. So that the shaft cannot withstand this amount of twisting moment or torsion. So it's under design, so the material will fail by this load. So if you want to have a safe component, you have to reduce the load, or you have to change the material, or you can modify the geometry of the shaft. So this is how can you do a shaft analysis by using Ansys workbench. And also you can see other results like the total equivalent strain, and also let us check let us check some. Let us leave it. So you can let us solve this elastic strain, or the total strain of the shaft. So as you see from here, the region where there is a maximum shear stress will have a maximum shearing strain. And also if you want to see the animated result, you can press here. So this is how can the shearing strain will induce, or the amount of shearing strain on the shaft. And this is what I intended to share to you. If you believe that is interesting for you, and also if you want to get some updated information, please subscribe my channel. Thank you for watching my video for this time now. See you later.